Okay.
You graded my web work?
No, it automatically goes in.
Oh,
Web work
okay.
automatically goes in. But I do a final check because I've found that like your first attempt at web work, let's say you only get half of it, and then it records a score of 5, and then you go back in and finish. I don't think it ever updates.
So you have to.
So I go back in after it's due and just make sure everybody's grades right.
Around 15.
Yeah. Yeah. Okay, so Section 1.6 was yesterday. Section 1.7 is today. Very similar. We're talking about inequalities. But in order for you to do web work, you really need to understand something called interval notation. I'm going to talk about it now, but I also put a video at the end of 1.6. So if you're in the middle, and you're doing a problem and you're not with me, and you can't remember and you don't want to watch this video again, there's another video that you can watch that just talks about interval notation. Okay? So interval notation, if I say x is greater than 4, the best way to understand interval notation is just to do a quick graph of it. Call that 0, 4 is somewhere here. Interval notation, we use brackets if it's or equal to. Like if I put a line under here. We use parentheses if it's not or equal to. That's not the most precise definition, but something that's in words you understand. Okay, and what I mean by that is for me to write a function that's x is greater than 4, if I'm going to graph it, I'm going to put an open circle at 4, right? And it's everything to the right of 4. Okay, for interval notation, I just start left to right. Because it's a not or equal to, it's going to be a parenthesis. Okay, it's going to start at 4, and it's going to go forever to the right. So what number is forever to the right? Positive infinity. If it were to go to the left, negative infinity. So it's going to go from 4 to infinity, and infinity always has parentheses. Anybody have a guess why?
Because can it be equal to infinity?
Yeah, infinity is not a finite number, so it could never be equal to infinity. It's always going to go to infinity but never include it because it's never ending.
Infinity times infinity.
It's still infinity.
Yeah, so it's equal infinity.
Infinity is not a number, is my point. It's not a finite number.
Considered an imaginary
I think infinity
No.
should be called.
No. So this is how I would write this answer in interval notation.
Infinity divided by infinity is 1.
And if I have, let's do x is less than or equal to negative 2. So here's 0. Negative 2 is going to be to the left. I'm going to do a closed circle, and it's going to go to the left, right? Correct?
Yes.
Negative infinity is this way. So I always write interval notation from left to right when I'm looking at the graph. From left to right, okay? So when I read this, it's going to start at negative infinity, and it's going to end at negative 2, and it includes negative 2, so it's going to have a bracket.
Wait, why did you have a parenthesis and then a bracket?
Parenthesis always goes with infinity. Brackets will never go with infinity.
But you're using the bracket because it's equal to.
And you can never be equal to infinity.
includes 2.
It can never include infinity because infinity is not finite.
But infinity
This is
can
one I
include
understand.
infinity, can it?
Infinity is not a finite number. That's the end of that. It will never be in a bracket. It will always be in parentheses. Okay? So now let's talk about how to solve compound inequalities and how to write those in interval notation. You'll see compound inequalities written like this, or you might see compound inequalities written like something like that. This is called an and, because it's going to be, it's one and the other. This is an or, one or the other. Okay, well, you're going to see them both ways. So let's talk about this first one and how we would solve it. So you could go ahead and write two different inequalities. That's one option. Okay? That means the same thing. This is an and in between. So we could write it like that. But the easiest way in my mind is to just solve it the way it is. So what we're going to do is operate this algebraically like we would be solving for x. But what we do to one side of the inequality, we've got to make sure and do the other side.
Oh, so you're minus 3.
So if I subtract 3, yep, I'm going to subtract it to both sides. And now, if I divide by 2, I've got to divide by 2 on both sides. So negative 5 halves is less than x is less than 2. Okay, so now in interval notation, this is what we do. I'm going to graph it. You don't have to graph it, but I'm doing that so you can start visualizing what it looks like. I have 0. We'll call this negative 5 halves. We'll call this 2. Well, to graph this, x is less than negative 5 halves is less than x. It's going to be here, and x is less than 2. So it's going to be between these two. Right? In interval notation, left to right,
So and is connected and or is split?
Oh, so you don't put the infinity in there or anything? You just
no, because it's between those two numbers.
Yeah. That makes sense. So just-
Okay, so let's do one. Let's say I've solved a compound inequality and I get x is less than 2 or x is greater than 5 or equal to. So if I were to graph this, I have 2 open to the left or 5 closed to the right. You see that? Maybe I'll do this part in red. Okay, this was my answer when I got all done. And this is how I would graph it, right? Now if I go left to right, this is how I'm going to do interval notation. From the left, it's negative infinity, always parenthesis. It goes to 2, open parenthesis, because it's not including. Now when I do an or, like this is, you always put a capital U between the two intervals. That just means or.
Okay.
And then I start at 5, but it's got to be a bracket because it's including 5. And then I'm going to go to infinity with a parenthesis. This is interval notation for this.
That one?
You always go left to right, and you just start, very left is negative infinity. I'm going to stop at 2, parenthesis, union with, that's what the U is, bracket on 5, going to positive infinity.
So for like or, I just put a U in between?
Uh-huh. Capital U.
Yeah.
Do I have to put a space?
No.
Space?
It won't count it. I've tried. Okay, so.
Does anybody have a problem they're working on that they're not?
This is, I'm having a problem with.
Okay, give me your problem,
My only
Thomas.
problem is with the brackets and the parentheses.
Let's try quick question.
5 sevenths, B,
B?
minus 8/5 is less than or greater to, greater, yeah. Negative 10/7,
B? Okay, just like equations, the first thing I would probably do on this problem is get rid of my denominator. I'm multiplying everything by what?
7?
35.
35. Does everybody see the common denominator here is 35? So I'm going to multiply everything by 35.
Would you make them all 35 first?
Yeah,
Make
you
them
multiply
thir-
the seven
Like
by the sevens
the
by the
7 by
fives
5 and
and
5 by 7.
5 by
No,
No.
make them all 35. No,
Make
Like
the denominator all
No.
35. So
no. This is a faster way.
Okay.
Okay? This is the process. This is what you do. What this means is I'm going to take 35 divided by 7 multiplied by 5. 35 divided by 7 multiplied by 5. Do you see that? It's, or I could say 35 times 5 divided by 7,
That's okay.
but 35 divided by 7 is 5. 5 times 5 is,
25.
so this becomes 25b. 35 divided by 5 is 7 times 8.
56.
35 divided by 7 is 5 times negative 10.
Okay, I see it now.
Now my fractions are gone.
Black, okay.
and I can add 50B, so I get 75B. Don't do this to me now, board. And add 56. Right, I added 50 over, and then I added 56 over. So I have B is less than or equal to 56 over 75, which is less than 1, right? If I just do a quick sketch, it's going to be less than or equal to 1, or 50, sorry, we'll call it 56 75ths. 1's over here somewhere. So in interval notation, it would be negative infinity to 56 over 75 bracket.
Can you do an interval?
So when's the right time to use brackets and the right time to use?
Brackets when it's or equal to, parentheses when it's not or equal to.
Okay.
Say it again, Katie.
So like 5 is less than or equal to P plus 1 is less than or equal to 10.
Okay.
So then we solve it in terms of 4 is less than or equal to P is less than or equal to 9.
Yep.
And how do I put that into terms
Really, you don't get good
Okay.
math, so.
On my 16th attempt, I get that one.
Good job.
Anybody else need me to run through one of them for everybody?
I
So,
just
like,
don't
what is-
understand how to put this if you don't want to do that as a class thing.
No, we can do that one. Negative 10 and negative 6. And what's the other?
7 and 8, it doesn't matter if the circles are closed.
Yeah, it does matter. Are these closed?
That one's open and the 8 one is closed.
Okay, so I'm reading left to right. Negative 10 to negative 6, union with 7 to 8, bracket.
So, like, what is this?
Okay, so I just didn't put the bracket on the right side.
Okay, if it's closed, you've got to put the bracket.
Okay.
Tanner, what'd you have?
So, what is this one, like, symbol that looks
It's like an E almost?
Yeah, like this.
Yeah, that. I
That's called, it's another way you can write, it's an element of, yeah. So if x is greater than 4, let me just see, does it give you an example? Is equivalent to x is, they just want it in interval notation. That little e just means it's an element of,
So kind of like equal to.
yeah. or-
Oh, okay.
Yeah.
Okay.
But what does it mean the left endpoint of an interval can't be positive infinity?
Because you always go from left to right. This is positive infinity, this is negative infinity.
Oh.
If I'm going left to right, I could never have,
Infinity is on the right side.
yeah. Yes, Gideon.
9W is less than 4, or W minus 2 is greater than
Say it again, 9W is less than 4.
or W minus 2 is greater than or equal to 5.
Okay, so what's or what's the answer to the left side? W is,
9,
what do I do to solve for W?
subtract 4.
Okay. What operation is being performed on the W? Addition?
Oh, multiplication.
So how do I undo multiplication?
Divide.
Divide by 9. Right? And then over here, what's being performed on the W?
Subtract.
Yeah, so I'm going to add 2. I'm going to do just a quick sketch. 4/9 is a little more than a half. So we'll make this 4/9. And it's less than that. And it's greater than or equal to 7. Right? So interval notation then is going to be negative infinity to 4/9, parenthesis, because it's not including, union with 7 to positive infinity, and no bracket, parenthesis. So bracket 7 because it's including 7, parenthesis on 4/9 because it doesn't include 4/9.
So how do I do infinity?
INF.
Wait, oh, that's like some of my, I don't know.
How would I put
this
that?
Fractions.
Do you have different?
In the
Graph,
computer?
it's considering
Uh,
this incorrect.
I've got some on the board over there, and if you don't, and there's some on that table.
The
Say that again.
brackets,
How would you do this in the computer?
The interval notation, it'd be negative infinity to 1. And so did you draw it on a number line? Draw your answer on a number line.
So wait, how do you write a set builder notation? Because it does give you an example, but I just don't know like how to translate that.
Well, what's your answer? This
Well, I
one?
mean, I'm not
So
entirely
finish
done
it, and then I will,
Okay, so
I'm going to stop the recording here.